Okay, so I've just outlined a brief agenda here because there's quite a lot of slides, and I understand that a lot of my audience may be diverse from different spectrums, such as those involved as system engineers and others who are actually from the construction informatics background. In a nutshell, I'm going to present two business cases. Hopefully, I will have it in the timeline, but the first one will be based on the conceptual architecture requirements for a French digital building logbook, and the second one is a circular systemic solutions for the construction industry. Okay, but in order for me to do that, I'd like to start on this slide, and I'd like to give a background of what system engineering means to me and how it involves into MBSE. And I've done this by referencing a paper that I submitted at the System Development in Cambridge in 2018. And as you can see, the title of that paper is quite linked with the title of today's presentation. But what did that paper mean? Well, effectively, the baseline for this presentation was the systematic aspects of thinking. You see, in the construction industry, and what I allude to in the actual paper is that we were very much advanced on systematic thinking. The RIBA in the UK, they had, stages of the life cycle process, quite similar to the IEC and ISO 15288. So we already advanced in that domain. The Office of Government Commerce, they also have for procurement various different levels that were actually able to align with the RIBA stages. And then you had the Building Smart. Now the Building Smart, they came with regards to the different levels of details. I think the initiative that I worked on for University in Salford was the government report in 2012. And they were looking at levels of detail for different models, for different simulations. Of course, they were aligned with the RIBA stages as well. So from a point of view of conformity, the construction industry was always good at that. However, were we always good at the systematic thinking point of view? Well, I've shown here a blown up version of a Revit model. And I've linked here kind of quotation or citation from an Nkosi where it says system of systems is a collection of task-orientated or dedicated systems that pool their resources and capabilities to create a new and more complex system which offers more functionality and performance than simply the sum of the constituent systems. It's a bit actually like Aristotle, where he said the whole is, greater than the sum of the parts. And how do we relate to that? Well, effectively, in regards to the construction industry, we know that, the different types of window space we use will have a knock-on effect for the thermal conductivity. We know the different types of materials we choose will have a knock-on effect. And we know through the floor-to-wall ratio, we may lose head loss in these buildings as well. And we have to then choose, the type of air conditioning ventilation system that matches that. So why do I mention, HVAC? Well, effectively, in the construction industry, 67% of the whole life cycle cost is accumulated to these two elements, mechanical and electrical, and they have a profound impact on the structure of a building. If you start moving some of the plant inside to get more space, then you have to increase the structural domains of your building. Likewise, if you put the plant on the roof, you have to start thinking about the type of design economics you have to choose for the materials to hold this. But regards to systems, you can see that as the most decomposed element of it, it starts to build up and build up again, and then becomes into something that's complex, but does give you the functionality performance that you choose. And okay, so we do have a bit of semantic thinking where we identify the different types of connections. And in general, with system engineering, we talk about performance, functional, structure, the flow. But really, it wasn't until I was actually at University of Toronto that I realized when I was helping PhD students, I brought this book from the UK with me. And of course, I did so because Les Ruddock was on it. And effectively, he was a professor at Salford University, where one of my supervisors were. But he had this really profound chapter by Professor Alan Payne from UCL. And Alan Payne was citing these guys. But Alan Payne had this, not an idea, he actually really spelled it out. He said that regards to the physical aspects, the physics, we can actually do quite good requirements. But when we start looking at socio-economics aspects of that and the performance of the socio aspects of it, it becomes really difficult to actually have, the content specification at the stage that we're actually looking at, that maybe we'll have to involve with that. Now, Alan was also very much into looking at things like the line of space. And when he actually cited these guys here, he made my whole world change with the influence he actually kind of came on me, because he was then looking at a building from a representation as a room, but not as a room, but as a network. And within this network, you were able to look at a different point of view for a single system of spaces from different points of view. So now I'm starting to look at the rooms themselves, the corridors, as nodes, as connection nodes. And when I was at UC Irvine, they were getting us to do things in my system engineering cert. We were looking at PetriNet graphs, and we were doing analysis for measurements of effectiveness and a measurement of performance using simulation-based software for that. But it didn't really mean much to me because it was more about docking of ships. But when I looked at Alan's stuff and how he'd actually addressed the building itself within the environment, now I could see how all the connections and how the path we choose make a difference. And if we take that one step further and we look at a relation to a hospital, when an ambulance arrives at the entrance, what is the fastest route to get that ambulance patient to the ER system? And from there, we're able to then do the calculations of where we need the type of electronics and mechanical aspects. And then we start designing the building from the SEBoK aspect of it. And again, if I push that even further on what Alan was saying, all of it starts to be related and connected. And like Aristotle said, it wasn't just the sum of the parts, it was actually the reasoning, why we're doing it. The reasoning makes the difference, the relationships makes the difference. If we look at energy systems, they're connected to transport systems, they're connected to information systems, again, it's connected to urban systems. So when we start focusing on things like the smart grid, the smart city, now we're starting to see a big picture, and now we understand what semantic thinking is. And then, of course, we can build into system science. We're identifying the relationships and behaviors. We're analyzing the patterns. We're also using tools to do deep analysis, such as Capella, to do the system thinking. And that's where I would like to start today's presentation. Okay, so a quick disclaimer. I would like to say that this presentation is about 2 business cases that are best practices, but I got positive results, but they're actually, in my opinion, 2 narratives. So the stories are connected, like all good stories. They're connected with the use of Arcadia, the use of Capella that I gained from the training that I had from OBO. And when I say that, the first case study, the demo blog project, the feature requirements, there were only requirements that I needed to capture at the early stage. And there's a slide that I show that has a really deep impact of even just making slight changes at the early stages. And again, there's other things like why I chose the training of OBO. Well, I knew the excellence. I knew the training was delivered through THALES. I knew OBO had a mark of excellence. But again, for me, it was really on a live horizon projects to advance the requirements and the collaboration, focus on the collaboration between partners. Now, I've listed things here that I could have used to make things better, like RecView, and of course, using requirements interchange format to put back into Capella. And I've also highlighted here that OBO has lots of webinars, and this is an excellent one here, showing things that has already been done using IBM doors, and I think it's Florian from Siemens, and even the last webinar was excellent from reuse with the digital thread. So if you want to know about the deep aspects of that, I would advise you to look at these. But for me, the in-flight entertainment system, and remember, I'm very much in the infancy. I got this 2 weeks intense training course, but it changed everything. But the key thing I can say from that module that everyone probably knows who takes the training is these key parts here, how to have the decompositions of the connections for the interchange, the components, the functions, the exchange items, and so forth. And this will come evidently clearer as I go through the presentation. But I'd just like to point out, in my proposition for my recent submission in February for Horizon project, I may have took some liberties with this. Okay, so again, just to highlight the demo blog project, this is the first case study. There's a lot of excellent work going on in this since I left. It's an excellent project. It's been coordinated by Delft University from the Netherlands. I published a paper on the work that I contributed for CSDB. I was honored to actually represent CSDB, and there's a paper there I published on it. The actual description here, this is actually my version of the description from a system engineer, because I looked at it from highlighting system science approach of understanding all aspects of systems, the system thinking array, the methods, the relationships, again, key on the relationships, the perspective in order to provide these requirements and identify the systems which are composed of parts and wholes. Okay, so I really need to give you kind of some explanation here. As I mentioned, there'll be different audience tuning in today. So I need those who are not involved in construction informatics just to know a little bit about what is a digital building logbook. But essentially, before I go into this diagram, I think it's done by Erskine, I would like to say that it's a digital building logbook is a common repository of all relevant data. It enables the data from information documents to be recorded, accessed, enriched, organized in a specific category, and it represents and you record the major events in the building's life cycle. So if you start from here, you can see those professions involved, like others, they would use building renovation passports. You have architects who use the building information modeling. And then, of course, those involved in construction manufacturing of products and so forth, they would use the digital product passport. And these are connected to the GIS systems, to the actual building material passports, into the digital building logbook. And of course, the end users are government, utility firms, private equity, and so forth. Okay, so just to pause at that, what I'm addressing here at the bottom, there is a need for change. There is certainly a need for methodologies, new methodologies, and new architectures, in my opinion. The majority of the data that we store currently for indoor air quality, operational energy use, smart buildings, life cycle emissions, the ratings, the certificates, the circularity, it's all static in a logbook. But now we're moving into things like meters, intelligent devices, dynamics, need to be automatically and regularly updated. So the whole architecture's changed. I mean, we've gone from our basic architecture to now where we're actually focusing on architecture that involves event-driven architecture. I think we're actually even more elaborate looking at data mesh and data IQ with the use of Neo4j. I think they're actually looking at LMMs and data mesh. All the architectures are now changing, and we have to move with that, and we have to have the tools that move with that as well. The IoT, the bandwidth, everything has changed the construction industry to be more of a digital transformation. Okay, so the actual case study, as you can see, I've linked the URLs here if people want to know more about the based on Données Nationale Bâtiments or about Capella. They were the two. Well, the BDNB is governed by CSDB. In my contact was Matthew Turnell at Sophia Police, and then CLEA was Bertrand Leclerc. But of course, CLEA in France, they already have their digital logbook. They're very successful at it as a real estate firm. They wanted to connect to the centralized database of the BDNB, which CSDB governs. And people in France will know that this relates to forestry, tax, energy, gas, the energy certificates, the noise levels, the semantic things, earthquakes, so forth. Through ETL of data warehouse, we have to pool all them together into one central database of 20 million addresses, something like 110 topologies. So that was, in a nutshell, the case study that was the French one. However, what I've actually done here is took an extract from the subtask. This is how it was written. Define the specification for automated renovation of ICE tools. And EST was the Energy Saving Trust in the UK. They were actually leading this because their demonstration was only getting built at the time, chimney, but it was going to be very similar to the French. So we had an excellent coordination and cooperation between the two, we said two countries, but obviously the two case studies. So CSDB and Capella were joined together from France. But it says here all the typical things like requirements, capabilities, behavior, architecture, structure, verification, and validation. And that was what we were trying to do and succeed with. So why system engineering for this kind of thing? Well, I've linked here the requirements management, and it says it's pervasive mechanism. It forces conversation. And it's not just between program managers and chief system engineers, it's through everyone in the team. I was able to really communicate to those in the UK. I know that it's probably easy, but you'll show on the next case study that it was dispersed region of Europe, because it's quite easy for me to get to UK. But with the manner of the detail that we were actually using from the information that I was providing from the French case study. And of course, MBSE, well, it's a formalized application of modeling to support system requirements, design analysis, verification, validation at the concept stage, all the way through the life cycle. Now, I've took this here and I was trying to illustrate that my requirements, you know, they're probably not near doing COSI. I was a version 3.1 specification requirements. But what I was trying to do is just have something to start the discussions. And again, I'm quite happy that because the Defense Acquisition University in the United States, they had shown here at concept stage, you know, you've committed to 8% of your concept, your design, but you've actually cost-wise committed to 70%. And if you follow that through development stage, you're only done 20% of how you're going to design your building or product, but you're committed to the cost of 85%, and any changes have a knock-on effect. And this is why anything we can do to improve the concept stage, improve the communication, improve the efficiency, which I did through the Arcadia methodology and Capella, it has a deep impact on the overall cost of the product. In my case, building or the digital building logbook, in your case, the product that you're focusing on. Okay, so in COSI requirements, they have this beautiful graph coming from WeCraft, and it shows like design inputs. You need to have a set of needs. They have to be transferred to design inputs requirements. So design to what? And this focuses on design inputs, the logical and physical architectures. And of course, this will come very much clear when I start showing the Arcadia methodology, and then it gets transformed to the architecture design. Design output specifications include requirements, algorithms, drawings, so forth. So you're focused on the maturing, logical, and physical. And again, you will see that through using the training I have from OBO with Arcadia and Capella. And I'm specifically referencing this to the construction industry because I know people in system engineering will be very much advanced in this. But it also shows you how in-depth requirements have to be. You know, a lot of people say like that subtask was to create specification. I think at best we might get a detailed requirement. It's not easy to have a specification in the timeline that you suggest. And that goes back again to Professor Allen, what he said when he was identifying that we may need to involve, you know, the requirements going through the full stages. Okay, so the first thing I did, done my competency in what I am with a system engineer. I looked at creating an interface control document for this requirements energy renovation toolkit. I came up with a brief architecture showing the BDNB connected to the ETL, connecting also to what Calatel had with their equipment. Calatel is the company, CLEA is the software, and how they would actually use smart metering and so forth in their databases, and then using APIs. And this was just really a kind of a mashup. I would have meetings with Matthew, again at CSTB, to discuss, you know, can this be actually achieved? So then I do the other system engineering thing you do. I look at the input output. So I focus on, well, what are the inputs? As you can see, Castra and all comes from the BDNB, digital product passport, manufacturing cost, list of equipment. Then I look at what are the controls. You've got the product category controls. You've got EU digital product passport, ISOs, and so forth. You've the enablers of using the ETLs, the energy simulations, the activities that would need to be done, and then what is the output. So these I'm listing at this stage are just general system engineering kind of practices, services. So what does it mean to the digital models, and what does it mean actually to, you know, MBSE? Well, MBSE, of course, is a methodology that focuses on creating and exploiting digital systems. So as a primary means, you exchange information, feedback, and requirements, as opposed to, you know, the ARNIC outdated document-centric, and then you come into the model-centric focus. And of course, with using Arcadia methodology, you can see now how pronounced the collaboration is between all various different actors by using the Arcadia methodology. It's an entire process of capturing and communicating and making sure all digital models use and represent the system throughout the life cycle. Unfortunately, I hadn't got my training at the time, so I still had to use the document-centric approach. I still created business process maps, which I would still do today, to be honest, but more in electronic form rather than Excel. But again, you can see here, this is live. The dates here was the 16th of June. Calatel, CSTB, R2M Solutions. We were working together to work out the swim lanes, the process of the interchanges between the different databases. I then create a process map following the sequence of events. People here in France will know what Linky and Ondi is, but regards to how the data repositories using SQL, so forth. And then I created a component breakdown for the French demo using the CLEA equipment, the natural repositories, CSTB, the communications, and the personal equipment of CLEA, and then put it in an actual requirement. So like when you see the function here, renovation works in the certificate, it then is lined with the equipment module. So it's a reference of cross-tabulation here. So I still did process service that we provide as a system engineer. But then I took the training with OBO, and it was delivered by THALES, by Monsieur Lino Yappi. And of course, it was supported tremendously by Monsieur Martin Le Bourgeois here at OBO. Martin was actually in Vancouver at the time when I was annoying him. But anyway, the training itself, it really did improve the situation. Just to give you some background, the first thing that Lino did, I think he was using the Klaxon platform. He had all these descriptions, these short texts, and then he had these titles across: purpose, function, behavior, structure, interface. And these going down the left here: operation analysis, system analysis, conceptual architecture, finalized architecture. And then we had to fill out these parts here. So this is the correct one, I presume, because I took a copy of it. But when we were actually pulling the information, you were thinking yourself at the different levels, what is needed for the stakeholders at operation analysis? Is a purpose, function? What's the questions to ask? How? What's the example you use? What does it interact with? And it was an excellent exercise before we actually jumped into the actual tool. And so OBO itself is a language, it's a method, Arcadia, as it says here, methodology, viewpoints, and it's the tool Capella, which is a purpose-built tool for it, an open source tool. Okay, so taken from that, where Leon had actually introduced operational analysis, system analysis, you can now see how I focused on it for the workflow structure. So the first thing I would have to do is define the stakeholders' needs, then formalize the system, develop it, system logical architecture. I went as far as the physical architecture, but I didn't submit it to our partners, actually internally in CSTB or to the UK partners. I just did it myself because we didn't need to. I only needed to get to the basic requirement stage of the logical architecture. And then, of course, there is the end product breakdown structure, which is phenomenal when you want to work in procurement subcontractors. But to keep moving, you can see here my models at the operational stage. You can see at the system analysis stage, the logical architecture stage, and then the physical stage, how it keeps on growing, more and more models, more and more information, data, all at it to turn to knowledge to make decisions. So this is how it works. And again, this goes back to what Monsieur Lino Yappi taught me. He said, look at purpose, function, behavior, structure, interface. So for me, with the French demo, what is the homeowner expecting for maintenance? What and when the interactions occur? What are the challenges? And what does it interact with? And what is the information and so forth? And so I build my models upon this. And at the very first phase, we're looking at the operation analysis. So as you can see here, these are the actual, as it says, the capabilities of the operation analysis. This is the operational entities, the energy renovation, the renovation provider, and this is the actor, the homeowner. So this is a very basic model at the very early stage, but then that gets decomposed into this function flow that shows you identify all equipment. So this kind of relates with the renovation works, the instruction what gets exchanged, perform regular updates and technical developments. It starts getting more and more in depth with knowledge. So that becomes your operational analysis, the interaction breakdown of the equipment models. And then you do the next one, the next model for the pricing and so forth, monitoring tool for the energy monitoring report, and you're showing your links. You have to keep in mind that if you change anything here, it would change all of the structure here. It's all linked. It's an interaction breakdown. So it's quite good for transparency. So that's the energy consumption. And then I work out the registration of building ID, because with the BDNB, the key thing was to have each ID for the building. So you're looking at an identity card, creating a report, problems that you may have as time constraints. Then again, we're looking at thermal study, performance of automated energy report and diagnostics for the energy performance certificate. But then all of these together get decomposed, and what you're left with when you open up your screen for the architecture, you just have to manipulate a bit, but you're left with this. You can actually start visualizing how everything is going to be connected. And remember, I told you at the second slide about the components being interchanged and connected to the functions. This is exactly how it's happening, and you know what's going to be exchanged and the outcomes, and it comes so rich with data. I'll move quickly now because I think I'm nearly 30 minutes. So again, you could do an entity scenario diagram showing how the owner reaches to the energy renovation toolkit, the provider, and exchanges. And again, these are populated at the beginning through the information decomposed at each stage. You can change it, but it will have a knock-on effect to what you change. And again, I did the same with the system analysis. Again, I will go through this a little bit faster because the slides and this will be recorded, so you'll have the slides. But I start with the system analysis. It grew because I need to now think of what is the system analysis of the French National Repositories for the BDNB, and what is the toolkit for Calatel from the system analysis. And so now you can see the function flow is actually getting in more depth. You then have a traceability to make sure that everything's lined. Again, this is automated, you know. So functions and traceability. You also have your key chain flow coming from National Repository to BDNB to the toolkit to the CLEA software, the function of that chain. you're able to actually do state mode. Here, I honestly wasn't able to highlight the seconds. I would have had to done something probably like the simulation seconds for the throughput on that, but I'm able to address it here and how it's actually done. And then your architecture becomes more and more knowledgeable at this stage. Again, you can see the exchanges, the EPC, through the system of the toolkit, using the list of equipment, the lifecycle product, and CLEA software. Again, if we move further now to the logical stage of which I submitted, you can see here you have your function, you're defining your logical functions, you're doing your entity, scenario diagram showing how it actually work with a loop here to concentrate on, and see it's actually increasing. Each stage it increases. Because more data has been added, you're able to look at your classes that you can give here as quantifying things which you can use for programming. And then here you have your element breakdown. I know you may think this is a bit abstract, and the one I actually did was more in depth, but the thing you have to realize this was actually presented to me from the information I had provided. And when you get to the end product stage, you have a really large element breakdown of all your decomposed components, and you can actually add images beside these blocks, or even click on the image, insert the image here, and it will bring you back to where you first defined the database, the DPE database. So it goes through a trail all the way through the process of all the different architecture structure and methodology of Arcadia. And again, now you can see when all these start forming together, the architecture is quite enriched. Okay, so here it is in a larger scale. And again, in construction industry, just like all other industries, when we develop products, the images add quite a lot. So I was able to put images beside it. And here you can see the key functional chain. The CLEA software is up here. The EPD functions and components are here. And of course, I added descriptions here to actually explain what they were. And then I gave links to show where they're from. And this is important. So if I just take this kind of section here, on the next page, I show what that is. I kind of blown it up. So for the EPD, you're looking at establishing LCC of the products, the exchange of protocol to do that. You're looking at life cycle analysis. I won't go through all these, but you can see how they're interacting with the renovation provider and what you need to exchange. And then you see I've highlighted things like ISOs, and I'm putting here where I get the actual PCR from and the product specific rules. And that was taken from actual live case in France here on HVAC. And you can see the appendices here, analyzing everything that should be included. And this is what I'm using to build up my knowledge of what I should put in my requirements and how it should be linked, and to show the guys in the UK and in France where this information is coming from, that it all has traceability, that regards to environmental product declarations, you can actually see how it's being used. And so here's the French demo requirements. And I just highlighted this part here. Not that it's special, because actually this is information from other sources, but you can see this PCR, the ISO, that was taken from here. So when I have the arrow here, it shows where I've pulled the information, and that's how I was able to identify it in the actual requirement. And of course, this document, the first version of this wouldn't have looked like this. I would have had to talk to Matthew, and Matthew would have said, no, Alan, he's a data scientist, by the way. No, we will change this, and you have your attributes that you need for good requirements. And we work and we show, and the different images that I produced using Capella and using the Arcadia methodology, we were able to comfortably stand over this and use it to communicate with the UK of what we needed in our French demo. Okay, this was the actual work that I talked about that I did by myself. I went another stage on the physical architecture, and you can see here it becomes way more enriched now. I'm looking at testing the ETL. I'm also looking at recommendation of applications and building out things. Well, we have a building ID. Can we create a product catalog using MongoDB? Can we create recommendation using graph technology? How will we do that? Will we use awesome procedure for Neo4j? Will we use, ciphering? Will we use option 2? Because any good consultant will have to give you more than one option. And it's nice to be able to actually show this through the Capella tool. And again, if we look under the hood of the tool, you can see this is still Capella management description. I was able to put these descriptions in, highlight the polygon persistence of different, languages, so forth, building ID, the product catalog. I was able to show here my idea. Okay, so building ID is building A that's in somewhere in Arcadia in Paris. Well, building B is, but building A is going to be, what's going to happen here actually, building ID of B has already had a replaced boiler, and now building A in the same category, which is probably the same type of building, wants to replace their boiler with a combi boiler as well. So in the construction terms, we know if they do replace it, what kind of product they do. We were able to rate that product, what kind of similarity, but also we have to keep in mind if they have a similar domestic boiler as B, then we'll probably have to replace all of the gas pipes as well. And then I tried to do a cipher of this. And I came up with this idea. I'm not going to go into this too much because actually Neo4j kind of have their own version of Graph Builder, and it's excellent and supersedes this. But the idea was to have real-time data come into Mango using connectors and ciphering it documents through Neo4j graphs. Okay, so to get to the actual perspective and keep with the topic, you're taking basic abstract kind of things here of the operational aspect and the operational entities and the actor. And through identifying the need and understanding, you can see the different layers of architecture. The operation analysis, what is the user system, the system needs, the logical architecture. Now we're moving on to the solution design phase, and we're coming more in depth to actually create our requirements, and then the physical architecture of how the system will be developed and built. And the next stage is obviously the end product breakdown. So the summary, I'll go quickly through this as well. Improved communications. Well, as I mentioned, with CSTB, it certainly helped with Calatel and the people involved, and also with Energy Saving Trust, Sean Emo there from the UK. The workflows, it was awesome using the operational analysis through the different levels and how the actual models were actually then being enriched and growing. And the interface control document had listed everything. I mean, I'm only showing captures here, but the interface control document listed security and everything, and it was helped by using the actual workflows process of the Arcadia. Improve the quality of the product, of course, incorporate and integrating components, shown how allowing atomic sections to be analyzed individually really gave pronounced effect of actually making it more efficient with the model's intelligence. Okay, reduce time. Yep, the baseline, because remember, I'd only got 2 weeks of intense training. I was able to produce this and I had to use it as a discussion document and actually put all the information together. So that also reduced risk when I was talking to the senior data scientists at CSTB. And then knowledge capture, well, the tool itself and the language based on, object-oriented system engineering model really helps capture and determine what is the focus, what needs to be addressed, what needs to be the challenges, stakeholders' needs, requirements, and architectural analysis, and of course, the interfaces. So in essence, I learned a lot through the methodology, the viewpoints of Capella, and the purpose-built tools and diagrams. Okay, so I'm quickly going to go on to business case 2. And again, this is not a live project. This was a submission to a Rise in Europe project just in February. And I started using the Arcadia methodology, the Capella tool again that I got from the training from OBO. So again, you can see this was done through F6S. I was delighted to represent them. And you can see the countries involved. You got Portugal, Denmark, the University UCN, Slovenia, SGG. You've got Portugal, France, NeoEco, Romania, Estonia, Ukraine, Slovenia. It's quite easy, as I said, to use the tool and what I produced to talk to UK, but to do this in a short period of a proposal time for a submission with a lot of pressure on a 4 million submission, this is where this really kicked in. And again, this outlines what I was looking at for the project itself, for the policy to build for people, for deconstruction of buildings in line with the principles of circular economy. And again, like I said at the very beginning, what Alan Penn said, you've got to look at the bigger picture. All of the systems are connected in some way for the value chains. And that's what I'm trying to zone in on. Okay, so just to let everyone know, the Rise in Europe project over 7 years has 100 billion in funding. I think for climate, energy, and mobility here, you can just Google it. I've left the line here. There's about 300 million available for 2025. And I think system engineers would add so much value here. And I think Horizon would benefit from having system engineers that become more competitive. The products themselves will be more efficient if more system engineers are involved. Okay, so the call was here. And again, I don't know, I can't reference this. I couldn't find it. I'd used it like about 5 years ago. But why I put it in here is because these calls all look at this same problem to me with the Horizon. You have generally different things like research, innovation, action, research, and innovation on its own. But to me, it's all about creative problem solving. You've got to ideate, then you develop, implement, and clarify. And that's the same with most products, the prototypes, and then, of course, look at the business models and the process we go through for the simulations, the formulations, the implementations, and using lean thinking and so forth. This is no different. And this is what all of these kind of look at to me when I focus on. You need to start coming up with ideas. You will have to have a prototypes, demonstrations, and you have to look at the bankability. Commission's not going to give you 4 million just to end a product there and then with a report. You need to have a bankable, sustainable aspect to your projects. Okay, so if we look at this document that was produced by the International Council of System Engineers in 2022. It looks at the principles of what system engineering is to the stakeholders' needs and solution space with the results of the life cycle. These icons stand for physical and social. And what it's grounded here is that when you look at the first thing for your statement as the product system, and then look at the operational environment that drives this, the integrating of physics, logic, social, cognitive, relationships again for the context, you have to look at your environment. And as I said, again, from the very first slide I was trying to explain, I hope I did it well, all of these in some way can be integrated and interactive with each other. You cannot look at it as on its own. When you look at a smart grid, you're looking at urban systems, you're looking at supply chain, you're looking at telecommunications, information systems, and of course, energy systems, and transportation and financial systems. And now things are even going to a bigger picture with downstream applications for space exploration systems. So what I'm suggesting here in a good method, a good techniques of system engineering, when you look at the first aspect, this is generally 2 pages. The Horizon gives you 2 pages of what they want. It's not an elevator pitch. They're telling you what they want. So they're saying here it has to be cities and regions. It has to look at developing a circular systemic solutions, construction building sector. And they're looking for integrate innovative tools, products, and techniques, extending the service life of the buildings, life cycle, circular economy, optimization, SMEs or the stakeholders. But you have to start looking at all of these systems because they are now all a part of it through a socio-economic aspect of it. So for me, I went back to the system engineering principles and we look at the first 2 phases. Again, the concept definition, step 1, business or mission analysis, step 2, the stakeholders' needs and requirements. Business and mission analysis, I started gathering data. I started looking at BNP, Arabas, what they were looking at with their index of the top 50 firms that they were supporting for circular economy and bio-based materials. They were looking at community platforms, products as a service. It was really, it's easy to say layman term word like awesome, but it was. I looked at that. I then looked at things like how other entities like EcoChain were fundamentally looking at move things from the source, from the actual raw where materials extracted from, to the material supply chain. And they were also saying things like, well, 80% of the circular economy impact is due to the actual procurement managers missing the point of the supply chain and being fragmented. So I was now looking at the business mission. But again, in relation to these projects, as you've seen, I have 14 partners all over Europe. How could we do something for 3 demonstrations this project and yet make it be functional after the project? So I start looking at enterprise architecture, and you can watch this video here from Dr. Raj Ramesh, and it's excellent. He's actually fundamentally pinpointed here that all of our companies, as we move forward, we need to look to transform. We're looking at startups that may be competitive against us, which is a good thing. But obviously, to get to the end users and results, we have to focus on changing and transferring and evolving, always evolving. So we have to look at how our departments evolve, how we look at the business architecture to do this. We look at the actual application architecture, the underlying data architectures, and the technology architectures. Because the 2, business and IT, are both complementary to each other. They move together, and that's how we have to transfer. And that's why I tried to fit it into a federated architecture that somewhat became like an agile architecture as well. But again, how do I relate this to Capella? Well, now you can see how I was starting to address the stakeholders' needs. The call I'd asked for the biosphere. I was looking at natural environment, the built environment, supply chain, product development team, business enterprises, network security for information systems, waste management, finance transactions, who would be the users. And again, from the previous slide, you can see all of that is related here. I'm pulling these kind of to identify who is the stakeholders. I also have to look at the state of the art. And I realized in London that they were already pulling things similar to what we were doing at BDNB with the London Underground Transport. They were pulling all the information through ETLs, then using graphs and digital twins to help make their decisions. I attended here in Paris. There's loads of open events to everybody in the France area. I attended this one on Neo4j, looking at the Swiss Life. They were also using the relational database, pulling the data warehouse for ETL, and then using graphs, and then publishing on their business screen, I guess. But you can see the actual capture here. They're able to monitor the supply chain by using the cipher of the graph, and they're able to see how the movements are actually happening. And of course, graph technology received an ISO last year, so I've highlighted that there. But so I had to create these storyboards, and I know I'm kind of moving on time, but I looked at using, RAG, more importantly, knowledge RAG to help against the hallucinations. So retrieval augmented, generation. I looked at where I could have material providers databases and using real-time APIs to pull the information and use better cipher and stuff through the knowledge graphs, train the LMMs, use chatbots, then ask a simple question in the area that I live, like Yvelines, I live in Montigny-le-Bretonneux, where we could look at elements of products available and certification and be able to give me a response. These are just my ideas. You can see the other one here. I'm looking at vector indexes for similarities, your nearest neighbor, neurology kind of things to get questions. And you can see here I've used this image that I've took from the actual system that I designed in Capella. And then again here I started looking at genetic AI, looking at the prompts, the structured objectives, looking at the memories for the LMMs, and then of course using the API tools to respond to the questions. But as you can see here, some of the people I was working with didn't really understand these. And at the speed I'm going through this, I don't believe many at this call would understand this. But when I started breaking it down into entity scenario diagrams in Capella, then they could actually see coming from here, digital twin here, using RAG, fundamentally using LMMs for supply chain, the agents, what would be the output, the CO2 for material providers. It becomes a lot more clearer. So the system architecture, what I did, I came up with this concept that was going to be based on ETL. I was going to look at regional databases for suppliers of catalogs with eco building materials through web services, deconstruction to identify reusable materials, and then of course, environmental product declaration catalogs as well. Also look at community engagement groups. And then you have the European Circular Economy stakeholder platform and web service platform where people are talking about issues for ITO platforms and so forth. I was going to pull them together and then use the graph RAG to actually cipher the information to give you recommendations and to look at the bill of materials for comparisons. And of course, I was representing F6S, so there are 5 million companies on the platform. So how would we help them? How it would help the social economics, obviously. We're looking at venture capitalists and angel funds. And of course, here I was looking at cost benefit analysis. But the key point here, I then was able to transfer this into the federated architecture. So as you can see, I was able to show all the components, how they will interact, the public bodies, the environment product declaration, how to connect, the pilot studies, the site, the UX testing in Ukraine, based on the new European BAHO capacity program, who was the product development team, what they were doing. Of course, some of the demonstrations I mentioned, there was 3. Well, here you can see where the material provider was pulling information from route planning optimization, real-time tracking, risk analysis, using Graph Finder and then Monte Carlo simulations. But the key here is that Visibera, quite a large construction company, they were looking at action and reasoning. So React AI to do agentic AI to do the predictive analysis on their demonstration, and we were able to show it here through using the actual dynamic pricing of how that was functionally working. And of course here, as you can see, you can couple and uncouple each of the points, and just like a line of business that you have with a federated architecture, you can show how each case study is interacted. I mean, we had here blockchains for circular payments that related to another architecture of the demonstration. And so what I gave here showed how everything could be together, how I could explain it to them. And then each of the demonstrations took this and built their own architectures, very advanced and more clearly. But at least with this logical, I was able to connect to them. So the summary, okay, improve communications. Well, the actual document tells you that you need to build appropriate architecture to find the most acceptable compromise between viewpoints. And that's evidently true in Arcadia and Capella. Communicating the business needs, the stakeholder needs at the conceptual stage, at the very early stage, where you only committed to 20%, but it represents 70% of your committed costs. It's crucial. Increased ability to manage. Well, the logical architecture and the framework identify the different supply chains, as I showed in the architecture in the previous page. Identify the relationships, and this goes back to the reasoning. Why? The reasoning, that's the key thing, the relationships between the components and the consortium partners, how they could actually build upon this to know exactly what their business could deliver, even at a minimum value product stage. All right, quality. The modeling can demonstrate how different entities support their business enterprise. Furthermore, it also simplifies the complexity to understand the business and technology, how they work together, and demonstrate it as in the 3 demonstrations that we did in the actual submission. Their case studies were aligned in the overall architecture to advance the overall business model as well. So we're advancing individually their business models, but also the overall proposals of what the project will do. So the proposal was 14 partners. It had 8 different countries. and took less than 3 months to do. And the relationship link between the business mission and stakeholder needs triggered excellent discussions. If anything, that's what it was doing. And if anything you can take away, that's what it was doing. It was triggering discussions about entity scenarios of how things should actually focus and work. It gave us more an in-depth. Once a week we had a meeting, but this was really in-depth because of what we were shown with the Capella tool. Reduce risks. Going forward, I've shown things like interoperability and the semi-autonomous aspect of the line of business that you have. I also showed the data encryption and secure electronic payments. That's why I looked at blockchains. It's actually because of that triggered me to actually look for a security partner that I got from ICI Bucharest. There was a reason for it. And then Architect, it triggers future discussion points. So you have the network information standards. So any important entities will have to look at waste management. So you know that I've mentioned waste management. So as a kind of taxonomy mapping, this now tells me going forward, if I win the project or look at other projects, I have to look at this. Corporate Sustainability Reporting Directive, because under the European standards for this, the reporting you need biodiversity and ecosystems. And then, of course, also circular economy. So through actually having these on my Tableau, having them on my canvas, I'm able to map these, right? So the enhanced knowledge capture, it does this with the logical architecture. Your components are in blue, your functions are green, exchange items or the interfaces are in red. It helps you actually identify what you're actually exchanging, interoperable, the interaction, the interfaces, which is always the key challenge in construction informatics, but allows you to do it in an incremental and iterative way. So there's things like I look at the diagram that mentions AI agents for exchange functions. I've only learned now I should have mentioned probably model context protocols, that these are being developed, and I should have looked at this. Dockers is creating this, but these are things I can revisit because I've already mentioned it and highlighted. Other architecture I see, they're very abstract, they have a lot of images, but because of using Capella, I can see introductorily each of the actual protocols or where the exchange should be to actually highlight if we win the project. So in the construction industry, three-dimensional thinking is paramount, and various exchanges between the components, they're not always fully analyzed and they're complex for supply chains, but using Arcadia and Capella provide the methodology to evolve for proofs of concept and feature the functional flows, the structured interface behavior, and I would say the relations. All right, so quickly, all right, for those in the construction industry, in COSI itself, through the Sustainable Development Goals, is now being registered with the World Federation of Engineering Organization, headquarters here in Paris. And of course, I represent in COSI LA chapter, but you also have the IEEE System Council, but you have to be a part of the member society, like the Computer Society or the Systems Man Cybernetics, which I'm a member of, to be on this council. I'm with the Toronto Council. And then you have the Stevens Institute of Technology. So with regards to the system engineering body of knowledge, who actually are the stewards of the guides for system engineering, it's kind of this triple helix kind of thing where academia, industry, and government comes together. So they're the stewards of this. Okay, so that's really it for me. I've come to the end of my journey. I've mentioned this here, the modern system, because I'm on the committee of this, and of course, Professor Mo Manzouri, who's actually the top professor at Stevens Institute. He's also a colleague on this with me, so to be papers for this. You can find me here or get in contact with me. I'm looking forward to the questions.
So first question we have, could the Capella diagrams be shared or are they confidential?
Can they be shared? Yes, of course. I am. To be honest, I only tentatively showed some of the stuff with the case study because that's still being reviewed. But you can have a look at all of them. It's there. I mean, a lot of these things are already published, guys. So I'd be delighted to share with you guys. I mean, again, without sounding like some kind of I don't know how I'm evangelist here. The idea for me from today, guys, is simple. The OBO training was magnific, facilitated THALES. But the key point is the Horizon project, guys. The system engineers are awesome engineers. The advancements that they will make, I can't overstate it, to the Horizon project, will add super added value, and certainly to the actual projects themselves. There's a lot of gaps missing that system engineers bring. And if you're using tools like system modeling tools such as Capella, that is excellent. So please take whatever you need, because that's my point of view. And of course, a key thing, the Capella tool is very good. It's an open source tool, which makes it enriched. But the point of view is that Arcadia, that methodology, I never experienced anything like that And that was the game changer for me, guys, the Arcadia methodology. I mean, there'll be loads of tools out there, but I'm not sure there's lots of methodologies like the Arcadia. And like I said, you know, we're moving in our domain of architectures. We're changing completely. Our basic architecture using the source code, you know, it's completely changed. The event-driven of using IoT. Now we're looking at data meshes, LMMs, and graph technologies for the reasoning and relationships. We have to change with it. And this is the best methodology and tool I've used to change with it.
Okay, thanks.